So before we move further, I would like us to look at the categories of differential equation. We have two main categories of differential equation. There are one, ordinary differential equation. It is abbreviated ODE. Any equation with the differential coefficient dy dx, that is, we have these normal looking d's. These normal looking d's, they are all called ordinary differential equation. So any differential equation with this type of d, with this type of differential coefficient, is called an ordinary differential equation. And the second one is partial differential equation. Any differential equation with these weird looking d's, they are all called partial differential equation, and it is abbreviated PDE. So let us get into the order of a differential. We are going to be looking at the order of a differential equation. The order of the highest differential coefficient in the equation is the order of the ODE. So if you have the highest differential coefficient in the equation, then that highest differential coefficient will give you the order of the ODE. Let us take an example so that you understand what I'm saying. So this is a first order ordinary differential equation. Why? Because the differential coefficient, the order of the differential coefficient is 1. So this gives the order of the differential equation. So this is of first order. First order. So this is a first order differential equation. Now look here. The differential coefficient is of order 2. You can see the differential, this is the 2y dx squared. So the highest differential coefficient here is of order 2. So this second one is called a second order. This is of second order. The third one, you see, we have dy dx, we have the 2y dx squared. But what is the highest order of the differential coefficient? It's 2. Because y dx is also a differential coefficient, but it is of a lesser order, or let's say power, than this. So you can see this is still a second order differential equation. And subsequently, if you have an equation whereby the third order, there is a third order differential coefficient, then that would be of order 3. Sorry. So if you have something like the 3y dx squared plus dy dx plus the 2y dx squared is equal to 0. This differential equation is of order 3 because the differential coefficient, the highest order of the differential coefficient is of 3. Although we have 2, we have 3, and we have 1. So between 3, 2, and 1, which the highest? And of course that is 3. So this is of order third order. So this is a first order because it has the differential coefficient of order 1. This is a second order because it has a differential coefficient of order 2. This right here is still a second order because it has the differential coefficient of order 2. The highest differential coefficient is of order 2. And this is a third order because the highest differential coefficient here is of order 3. So this is what tells you the order of a differential equation. It depends on the differential coefficient. This is order 1, order 2, and this is order 3. So now we'll go on to the degree of a differential equation. Right now we are going to be taking a look at degree of an ODE. This stands for ordinary differential equation. So if you hear me saying ODE, I mean ordinary differential equation. And we're only going to be covering ordinary differential equation in this class. We will not be talking about partial differential equation. So the degree of an ODE is the power of the highest differential coefficient in the ODE. You can see it is what? It is the power of the highest differential coefficient in the ODE. And just like we've talked about earlier, we said that the order of an ODE is attributed to the highest differential coefficient in the equation. So let us take a look. Now we are saying that the degree is the power of the highest differential coefficient. So the degree of an ODE is the power to which the order of that ODE is raised to. So let us take a look at. So this is the 3y dx cubed plus 2 the 2y dx squared all raised to the power of 3 plus dy dx is equal to sine x. This is equal to sine of x. Now the first thing you need to do is to identify the highest differential coefficient. So in this equation, what is the highest differential coefficient? Of course, it is the 3y dx cubed, and it is raised to power of what? This is raised to power of 1. This is the 2y dx squared. It is also another differential coefficient of order 2, but it is raised to power of 3. But it is not the highest. That's one thing you need to take note. You only look at the highest differential coefficient, and right now it is the 3y dx cubed. So, and it is only raised to the power of 1. Remember, we said that it is the power of the highest differential coefficient. This is the highest differential coefficient, and it is only raised to the power of 1. So this equation is of degree 1. This is degree 1 equation. Forget the fact that the 2y dx squared is raised to the power of 3. No, you don't look at that because it is not the highest differential coefficient. You look at the highest differential coefficient. So let us take a look at number 2. This is x dy dx all raised to the power of 2 minus y squared equals to 0. And as you can suggest, this is of degree 2. Why? This is the highest differential coefficient in this equation. It is even the only differential coefficient in this equation, and it is raised to the power of 2. So this equation is of what? Degree 2. It is of order 1 but degree 2. So it is equals to degree 2 order 1. This one is of order 3. Order 3, but it is of degree 1. You can see. So let's go to number 3. This is the 2y dx squared. It is raised to the power of 4. Dy dx raised to the power of 5 is equal to cos x. Now, the first step is to identify the highest differential coefficient. And this is the highest differential coefficient because it is the 2y dx squared. It is the highest differential coefficient, and it is raised to power of what? Power of 4. This is dy dx. This is the first derivative. It is just differential coefficient of of the first order, and it is raised to power of 5. But you don't look at it because it is not the highest differential coefficient. You look at this. This is the highest differential coefficient, and it is raised to power of 4. So this ODE here is of what? Degree 4. Degree 4. Order what? Order 2. So degree of an ODE is just the power of the highest differential coefficient, and the highest differential coefficient in the equation gives you the order, while the power of that high differential coefficient gives you the degree. So this is all about the degree of an ODE, and by now I'm very sure you have understood what the order of an ODE is. I'll see you in the next video.